We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
NASA just went dark. The announcement came abrupt, unmistakable, chilling in its implications. The agency has shut down, its operations suddenly suspended as 3I Atlas arrived at Mars. Emerging as if from science fiction, the interstellar object had made its closest approach, and at that very moment, the machinery of America's space ambitions ground to a halt. The timing left the world reeling. The cosmic visitor at Mars now cast against a backdrop of institutional silence. Before we start, smash the like and subscribe buttons for more updates.
According to astronomers, 3I Atlas has all kinds of surprises. We've only seen a handful of blurry shots. That there's the unusual chemical signatures. It's producing way more nickel than iron, and scientists don't really know why.
3I Atlas had been tracked for months, its trajectory plotted, its composition probed through distant observatories. Infrared data from the James Webb Space Telescope already revealed a coma dominated by carbon dioxide, along with hints of water ice, dust, and other volatile gases. Its chemical fingerprint unlike that of typical inbound comets. The mixing ratio of CO2 to H2O was much higher than expected, suggesting the nucleus might be unusually rich in carbon dioxide and possibly tempered by extreme radiation exposure in interstellar space. That anomaly promised to teach scientists much about origins in a foreign stellar neighborhood. And now it was advancing toward Mars, a rare chance to observe an interstellar wanderer from a vantage point within the solar system's inner realms. Meanwhile, NASA's Mars Reconnaissance Orbiter, with its HiRISE camera and other instruments, was primed to turn its surveillance toward the comet. The MRO's long tenure in Martian orbit had made it one of the most vital eyes in the skies over the red planet. Designed for Mars climate studies, geological mapping, and support of lander missions, it had already returned troves of data since its arrival in 2006. Now it stood ready to deliver unprecedented views of 3I Atlas from Martian orbit, if only the agency remained active. And yet, as NASA's internal systems glitched and public access to updates froze, scientists and observers found themselves holding their breath. The decision to shut down NASA was rooted in the sudden political stalemate on Capitol Hill, a funding impasse that turned overnight into a full stoppage. All non-essential programs were immediately suspended, staff furloughed, communications blacked out, and public websites frozen. Images, press releases, status updates, none would emerge until the stalemate abated. That meant the images and measurements that NASA's instruments were capturing, even as they flew past Mars, could not be processed, released, or shared. The gears were turning in silence. The data lay stranded in a bureaucratic void. From Mars, the interstellar comet advanced. Its path had been calculated to bring it within tens of millions of kilometers of the planet, close enough that Mars-orbiting spacecraft could capture relatively high-resolution images and spectra. The European Space Agency, via its Mars Express and ExoMars Trace Gas Orbiter, had already committed to observing the comet during its flyby window. Those orbiters would work hand in glove with what NASA's instruments were supposed to deliver. But with NASA offline, this collaborative mission now unbalanced, ESA would be forced to shoulder more burden, and large portions of NASA's potential contributions would lie dormant. The silence at NASA produced a surreal juxtaposition. Cosmic discovery unfolding at Mars and beyond. Yet the agency's infrastructure collapsed at the very moment of peak excitement. Amateur astronomers, science enthusiasts, university teams watching for updates received none. Those who had been awaiting the release of the first HiRISE frames of 3I Atlas from Mars were left in suspense. The public-facing portals that once often streamed images from Mars were shuttered. The world could observe the comet beyond Earth's orbit, though through telescopes and ESA's channels. But the full power of NASA's resources, the cascade of internal calibrations and data pipelines, was offline. Even more unsettling was the knowledge that Perseverance, the rover on Mars, might have captured the comet in its Martian night sky. A streak of light appeared in photographs taken by its navigation cameras during the window when 3I Atlas was predicted to pass overhead. That faint smudge after stacking images aligned with the comet's expected path. If confirmed, it would be among the first attempts to photograph an interstellar object from a surface on another world. But NASA's hush meant neither confirmation nor elaboration. The raw signals remained tucked away. The immediate implications were staggering. A collapse of the agency meant that time-critical operations, such as slewing spacecraft, adjusting pointing, prioritizing instrument observations, were immobilized. Commands that would refine trajectories, calibrate sensors, manage temperature control, or sequence exposure windows simply could not be dispatched. In one instant, the tight choreography between agency, engineers, mission control, and spacecraft was broken. The windows for certain observations might pass without use. Some instruments, reliant on warmth or power, could drift out of optimal precision. For the teams that had spent years designing the observation plans, calibrating auxiliary measurements, preparing for time-critical captures, the shutdown struck like a guillotine. Scientists who had synchronized their clocks to align exposures of Mars with the passing object now faced dead silence. The interstellar target glided by, more than a curiosity, a messenger from beyond, yet the very observatories that could unravel its secrets were silenced. The strategic implications for planetary and interstellar science loomed. The shutdown exposed how vulnerable even a powerhouse like NASA is to political instability. When the machinery of exploration falters, even the cosmos cannot wait. The opportunity to trace an object from beyond, to measure its outgassing, dust composition, morphology, tail formation as it interacted with the solar wind, may have lost some of its sharp potential. Because some data could not be relayed, gaps might remain in the spectral record in time-resolved imaging in multi-angle viewing geometry. Those gaps are not easily filled by ground-based telescopes. The resolution, the close proximity, the uniqueness of Mars' vantage simply cannot be matched from Earth. For Mars itself, the visitor's flyby offered an extraordinary chance to study how an interstellar object might interact with Martian gravitational, magnetic, or atmospheric environments, even though 3I Atlas would not directly hit Mars or enter its atmosphere. Minute perturbations in trajectory or dust effects on charged particle populations near Mars might carry hints of both the comet and the ambient space environment. But all those delicate measurements required constant attention, monitoring, and coordination. Without NASA's active oversight, some of that capacity evaporated. Beyond pure science, the event rang as a cautionary tale about the fragility of infrastructure. Even the most advanced space systems depend on stable governance. When funding lapses or political gridlock invades, the connections between engineers and spacecraft falter. Science is not immune to politics. The cosmic frontier depends on terrestrial order. The shutdown underscored that aspirations to push outward, toward Mars, the asteroid belt, interstellar comets, must rest on foundations that are shielded from sudden disruptions. Systems must have redundancies, autonomous modes, fallback protocols. But in this case, the shutdown served as a test far harsher than planned. In the cosmic theater, 3I Atlas moved on, tracing a path across the solar system as if oblivious to terrestrial troubles. The window for Mars passes. After being near Mars, the object will head inward toward the Sun and then outward, passing near Jupiter later in its trajectory. ESA's Jupiter Icy Moons Explorer JUICE was scheduled to observe it when it approached Jupiter, another opportunity for comparative data. Meanwhile, NASA's own deep space assets, had they remained active, might have contributed via remote sensing from afar. But with NASA offline, many of those capabilities lay unused. Scientific teams that had designed joint requests, coordinated between NASA and ESA, aligning overlapping coverage windows, found them compromised. The global ambition to share datasets, reconcile calibrations, merge perspectives across missions, fractured. European teams needed to proceed but lacked some of the cross-validation data. Universities waiting for NASA's data feeds got backlogged. Even those working at NASA were trapped between the drive of discovery and the silence of furlough. The event tinted institutional reputations. NASA, often portrayed as a steady steward of exploration, had now succumbed to shutdown at the very moment its actions mattered most. The optics were brutal. While NASA's public engagement halted, the rest of science watched, waited, and wondered. The contrast between dark agency pages and a bright comet gliding past Mars was stark. International partners might begin to rethink dependencies on NASA's cadence. greater emphasis on autonomous mission designs and diversified collaborations could emerge. The long-term trust in mission continuity might be questioned. For the public, the break sent shockwaves. A once trusted source of open space images and updates went silent just as an extraordinary cosmic encounter unfolded. The sense of wonder that accompanied every Mars photo download was interrupted. News outlets scrambled to understand whether this was a deliberate halt or some catastrophe. The myth of inexorable space progress collided with the banal reality of political funding. In a sense, the shutdown was itself an interloper, an uninvited object disrupting humanity's attempt to reach outward. The mood among scientists stiffened. Some researchers haunted email threads, trying to check whether partial systems remained alive, whether ground stations could still pull telemetry by some dark link. Others scrambled plans to salvage what could be done under European or independent observatory auspices. The uncertainty poisoned project schedules. Teams were torn. Attempt interim work relying only on remaining assets, or hunker down until the agency reactivated. In either case, momentum suffered. The clock of 3I Atlas's passage did not pause for bureaucratic evil. Even as NASA lay dormant, data trickled in via ESA and independent observatories. Ground-based telescopes continued to monitor 3Y Atlas as it moved on, providing lower resolution but continuous coverage. Radar arrays, spectral telescopes, and wide-field surveys all contributed complementary pieces. That flow of information could somewhat redeem the moment, but the loss of the unique views from Mars, perhaps the only chance to acquire near-field imaging of an interstellar object from another planet's orbit, would haunt the records. The dream of a full multi-instrument composite of 3I Atlas passed through Mars became fractured. In the broader arc of exploration, this shutdown could mark a pivot. If future mission planners take note, they may demand greater autonomy for spacecraft, built-in resilience, onboard decision-making capacity that does not rely on ground controllers. Redundant control centers, hardened funding protections, or even off-Earth administrative architecture may seem more prudent. After all, when Earthbound politics intrude mid-mission, the cosmos does not wait. To imagine 3I Atlas's moment at Mars is to feel the strangeness of cosmic silence. There it was, gliding through Martian skies, maybe even caught by rover eyes, while below the institution we trust to unravel its secrets went offline. The object rode its trajectory with indifferent grace. NASA's shutdown was merely one more disturbance in its path. The comet carried within it frozen histories of another star system, perhaps ejected long ago, traversing the galaxy before intersecting our solar neighborhood. That narrative clashed dramatically with the human drama of agency shutdown and operational blackout. The sheer scale of what was at stake loomed large. Understanding the comet's structure, nucleus shape, spin, dust emission behavior, gas composition, and reaction to solar radiation was all part of a treasure trove. Mars-based observation promised angles unavailable from Earth. Side views, parallax shifts, rapid time sequence imaging as the object crossed relative to Martian orbital motion. And yet those observations were caught in limbo. The void left by the shutdown was as tangible as the comet's shadow as it passed Mars. The event also underscored how international space cooperation must accommodate disruptions. NASA's silence could have cascaded, but ESA's continued operations provided at least partial coverage. Still, system design to rely on a single agency's output now looks risky. Redundancy across agencies, nations, and instruments will become even more essential, especially for rare, fast-moving encounters like interstellar objects. The margin for failure is small. Such objects appear rarely and often are first detected only close to arrival. When they pass, the opportunity closes. When the silence settled over NASA's control rooms, the absence was deafening. Rows of dark monitors reflected the sterile glow of emergency lights their operators sent home, their missions held hostage by circumstance. In that stillness, something profound was unfolding millions of kilometers away. 3I Atlas was threading its way past Mars, brushing the edge of another world's sky. The universe did not slow for the machinery of human bureaucracy. It continued, radiant and unstoppable, while one of humanity's greatest instruments of exploration went mute. The comet itself had already earned its place in the astronomical pantheon. Its discovery had been a triumph of early detection, spotted at an immense distance through the sweeping eyes of the Atlas survey. From the moment astronomers confirmed its hyperbolic trajectory, a course that could only mean it originated beyond the sun's domain, The object became a beacon for science. Unlike Oumuamua or 2I/Borisov before it, 3I Atlas was detected far enough in advance to plan coordinated observations. It represented the rarest of cosmic opportunities, a visitor from another star, caught within range of multiple orbiters and rovers. For months, teams at NASA's Jet Propulsion Laboratory had refined pointing algorithms and exposure sequences. Every instrument capable of detecting light, heat, or particles from Mars' orbit or surface had been cued for the encounter. That was before the shutdown. The world had grown used to NASA as a constant, a steady pulse of discovery. Even during crises, data had continued to flow. Hurricanes, political transitions, global pandemics, none had silenced the agency's transmissions from Mars or beyond. This time was different. This time, silence meant stasis. Every automated process, every relay through the deep space network, every interdepartmental transmission was bound by policy. Even if the spacecraft continued to send signals, no one was authorized to command, interpret, or publicly release them. The surreal irony was that while NASA's operations had stopped, its spacecraft hadn't. The Mars Reconnaissance Orbiter continued its automatic loops. Perseverance and Curiosity roved on schedule, their onboard computers running through preloaded routines. Solar panels on InSight before its final dormancy would have still tilted toward the faint Martian sun had they been functioning. The mechanical ballet of exploration was self-sustaining to a degree, but only for so long. Without ground coordination, science instruments defaulted to safe modes. The agency's architecture had been designed to preserve hardware first, discovery second. Thus, as 3I Atlas arced past Mars, the instruments that might have revealed its mysteries were locked in caution. It was as if two stories, one cosmic, one human, had collided. The interstellar object, indifferent and ancient, swept by a planet teeming with robotic emissaries of a silent civilization. Data packets accumulated in spacecraft memory buffers, awaiting commands that would never come. Telemetry filled with timestamps, temperature logs, radiation readings, yet no eyes on Earth received them. A new form of loneliness entered the lexicon of spaceflight, knowledge stranded in orbit, unacknowledged. Astronomers outside NASA tried to fill the void. The European Space Agency extended its own observation windows, straining Mars Express and the Trace Gas Orbiter beyond their planned allocations. Instruments designed for atmospheric chemistry were hastily reprogrammed to capture spectral signatures of the comet's coma. But without NASA's comparative datasets, cross-calibration became guesswork. Observations needed to be synchronized across wavelengths and angles to extract meaningful 3D data, and that depended on the missing American components. Meanwhile, at observatories on Earth, scientists strained to track the comet's path. The Hubble Space Telescope, technically under NASA's authority, fell silent with the rest of the agency, but instruments in Chile, Hawaii, and the Canary Islands kept vigil. Through atmospheric distortion, the comet's glow flickered, faint, greenish, and diffuse. Early spectrographs hinted at volatile compounds unseen in typical solar system comets, traces of exotic organics, ratios of methane and carbon monoxide skewed toward conditions found in outer protostellar regions. It seemed likely that 3I Atlas was born in the outer shell of another system, a frozen shard from a circumstellar disk long since dispersed. The event was poetic, almost mythic. A wanderer from another sun approached the planet that symbolized human exploration, only for the explorers to fall silent. The timing seemed too precise, too uncanny to be coincidence. Conspiracy theories erupted instantly. Some claimed that NASA's shutdown was not a bureaucratic impasse but a containment order, that something about the comet had triggered fear at the highest levels. Social media brimmed with speculation, signals detected in the comet's tail, strange perturbations in Mars's magnetosphere, even suggestions that the object wasn't natural. Scientists rolled their eyes, but without NASA's steady stream of official updates, rumor filled the vacuum. In truth, the comet's approach had produced real anomalies. Instruments on ESA's Mars orbiters recorded minor fluctuations in charged particle density, ripples across the planet's upper ionosphere coinciding with the comet's passage. The cause remained uncertain. Possibly interactions between the comet's outgassing plume and solar wind near Mars's magnetic cusp. Had NASA's MAVEN mission been fully operational, it could have clarified the phenomenon instantly. MAVEN's particle detectors and magnetic sensors were built precisely for such events. Instead, they ran on automated loops, gathering data that would remain unprocessed until the agency's systems reawakened. For those still awake to the sky, the comet's progress was mesmerizing. Its coma expanded as it neared the sun, flaring brighter each day. Even from Mars's distance, sunlight scattered through the halo of dust, creating an ethereal veil that could be glimpsed faintly by Earth-based telescopes. Its nucleus remained unresolved, smaller than Borisov's, larger than Oumuamua's, but the tail stretched millions of kilometers. Astronomers debated whether the rotation of its core suggested fragmentation. Each night, the news feeds that replaced NASA's absent bulletins brimmed with amateur images, glowing smudges tracked through constellation frames. Humanity's hunger for connection with the cosmos did not dim with the shutdown. Inside the frozen offices of the agency, the weight of the moment was felt most keenly by the scientists forced to stop mid-discovery. Some had spent decades preparing for this chance, their careers aligning with the rare coincidence of an interstellar object crossing paths with Mars. They had written the observation scripts line by line, designed the data pipelines that would integrate multiple missions, MRO, MAVEN, Perseverance, even the defunct InSight lander's seismic records, into a cohesive portrait. The shutdown invalidated all of it in an instant. Many continued their work unofficially, running simulations from home, sharing encrypted messages with colleagues overseas. They could not stop their minds from spinning toward the unknown. The more data trickled from other agencies, the clearer it became that 3Y Atlas was unique. Its isotopic signatures, even inferred from ground-based measurements, suggested a formation region around a red dwarf or other low-mass star. Its motion through space before entering the solar system pointed to the general direction of the constellation Lyra. Somewhere out there, beyond the scattered interstellar medium, lay the star that birthed it. This fragment of alien geology, older than recorded human history, was drifting past a planet that humanity had touched with its machines. The symbolism was profound. The crossing of two civilizations, one human and technological, the other cosmic and silent. Speculation grew about the potential for sample return or extended observation. Some argued that NASA's silence effectively erased that possibility. Even if the agency reactivated, the comet would be long past Mars, racing sunward at tens of kilometers per second. Others dreamed of intercept missions, using ion drives or solar sails to catch it before it exited the solar system. Private companies began whispering about independent probes, seeing opportunity in NASA's absence. The age of interstellar pursuit had begun, and 3Y Atlas was its herald. Yet, in the shadow of this excitement, a quieter anxiety spread among planetary scientists. The shutdown had revealed a fundamental truth, that humanity's link to the cosmos was more fragile than anyone had admitted. Space agencies operate on the edge of politics, bound by budgets and oversight. The machinery of curiosity, once thought unbreakable, could be switched off by a signature. The event forced a reckoning. Many within the international scientific community began pushing for an independent, globally funded observatory network, a cosmic commons immune to national gridlock. The argument was simple: discovery is a heritage of the species, not of a single nation. Meanwhile, Mars drifted beneath the comet's tail, its thin atmosphere shimmering faintly with auroral glows. Dust from the comet's outflow brushed past the planet's exosphere, tiny grains possibly entering the upper atmosphere. For a brief time, Mars experienced a subtle meteor shower of interstellar particles. The data from that moment, if fully recovered, could reveal the composition of alien matter interacting with another world. But again, NASA's portion of those observations remained trapped. The thought haunted scientists. Information from beyond the stars existed, but bureaucracy had rendered it inaccessible. As weeks passed, 3I Atlas continued its path toward the inner solar system. The comet's surface underwent rapid transformation as solar heating intensified. Jets erupted from fissures, creating bright outbursts captured by distant telescopes. Its brightness fluctuated unpredictably, as if rotating irregularly or fragmenting. The object's survival was uncertain. Most such bodies do not last long when exposed to the sun's heat after eons in the cold. Still, the fascination it inspired deepened. Artists, poets, and philosophers spoke of it as a mirror. a frozen relic crossing the orbit of a silent planet while humanity silenced itself. The deeper implication was not just scientific but existential. The shutdown symbolized humanity's fragility in the face of the cosmos. Here was a civilization capable of landing machines on Mars, yet unable to keep its own doors open at the very instant the universe offered a gift. The timing felt like an allegory, a reminder that progress is never guaranteed, that even the most advanced society can falter over the simplest of human disagreements. The stars do not bend to political will, they wait for no one. The engineers who had once commanded Mars missions spoke later, when the shutdown's details emerged, of how helpless they had felt. Their spacecraft continued to transmit health beacons, pings confirming they still lived, orbiting, observing, ready, but the lines were cut. Some had worked through prior shutdowns before, but never during an active scientific opportunity of this magnitude. They feared that the world would interpret NASA's silence as indifference, when in truth, it was agony. Many kept personal logs, recording the comet's progress as seen from publicly available data, as if maintaining vigil for their silenced instruments. Outside of official channels, the international astronomical community became a kind of surrogate NASA. The Japanese space agency JAXA, the Indian Space Research Organization ISRO, and the Chinese National Space Administration CNSA each contributed their telescopic assets. For once, the rivalry that often colored global space relations melted away. Everyone recognized the rarity of the moment, an interstellar messenger within reach of human observation, aligning with a planet already populated by our creations. They coordinated informally through shared databases and encrypted cloud platforms, ensuring that no matter what happened politically, the cosmos would still be recorded. Through all of this, 3I Atlas revealed more of its story. Its surface albedo, the measure of its reflectivity, turned out to be unusually dark, even by comet standards. It absorbed sunlight greedily, its icy crust coated with complex carbon compounds likely formed through radiation bombardment over millions of years. As it neared the sun, volatile ices deep within vaporized, sending jets of material streaming outward. Some scientists speculated that the comet's nucleus might be more porous than expected, riddled with cavities that amplified these eruptions. The rotational tumbling observed hinted that the object was slowly disintegrating, shedding mass as it spun. Every new detail carried implications for the understanding of planet formation beyond the solar system. If 3I Atlas's isotopic ratios differed significantly from local comets, it would mean that planetary chemistry across the galaxy followed diverse pathways. It might confirm that water, carbon compounds, and organics, the building blocks of life, are universal, scattered freely between stars. But without NASA's full data set, the conclusions remained partial. Scientists compared it to trying to hear a symphony with half the orchestra missing. As the comet reached perihelion, its closest point to the sun, it flared to naked-eye visibility from Earth's southern hemisphere. Millions looked up, seeing a faint green arc across the night sky. The irony was not lost on anyone. Even as NASA remained largely dormant, humanity as a whole experienced the spectacle firsthand. The sky itself became the broadcaster. For a brief season, the interstellar traveler was visible without telescope or camera, its light washing over deserts, oceans, and cities alike. People who had never cared for astronomy found themselves whispering its name. 3I Atlas became a symbol of mystery, of wonder, of resilience beyond institutions. Philosophers spoke of it as a visitation, not in a supernatural sense, but as an encounter with scale. It reminded humanity how small it was, yet how extraordinary it could be to notice. Some said the shutdown made the event more meaningful, stripping away the layers of interpretation, leaving only the raw fact: the universe had come calling, and Earth's instruments had gone quiet. Others found it tragic, a missed communion between intelligence and cosmos. Yet even tragedy can teach. The lesson was simple. No matter how advanced, a civilization must guard not just its technology, but its continuity of curiosity. Months later, when NASA's systems flickered back to life, engineers found the stored data. Spacecraft that had continued autonomously had accumulated terabytes of telemetry, imagery, and sensor readings. The backlog was immense. It would take years to parse. But the timing of recovery lay beyond the scope of that immediate moment. What mattered was the symbolism that had already been burned into the public mind, The interstellar visitor, the silent agency, the reminder that the universe does not pause for human politics. As the comet sped away from the sun, destined for another eternity in the deep, it left a luminous scar across collective imagination. It had passed through the domain of Mars, the planet of machines and dreams, and moved on. Humanity, briefly muted, would spend generations decoding what it left behind. The intersection of 3Y Atlas and NASA's silence became a story retold in classrooms, documentaries, and novels the night the universe arrived and the lights went out. The implications ran deep into policy and philosophy alike. Lawmakers began debating measures to insulate scientific institutions from future shutdowns, proposing international consortia that could maintain continuity regardless of national gridlock. Meanwhile, scientists revisited mission design, emphasizing autonomy and data preservation. If machines can think and act in the absence of human command, then discovery need not stop when politics does. The next generation of rovers and orbiters would carry more onboard intelligence, capable of self-directing observation campaigns in response to unpredictable events. In academic halls, 3I Atlas became the case study for resilience. Conferences convened under banners reading, "When the cosmos doesn't wait." Panels discussed how global coordination must evolve beyond dependence on any single agency. Even private space firms, often derided as commercial opportunists, recognized the significance. They began investing in independent deep space monitoring programs, aiming to ensure that the next interstellar object would never slip through humanity's grasp. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA shutting down after 3I Atlas reached Mars? We want to hear from you. Thank you for watching and see you next time.